In this video here, we're going to be looking at inverse function. We're going to start by graphing this equation in the warm-up. So this equation here is a linear equation because it's x to the first power. So we have a slope, which in this case is 3, or we can say that's 3 over 1. And our y-intercept, our b, is -1. So using our Algebra 2 skills, we're going to plot that y-intercept on our y-axis at -1. And I'm going to make a line. Now I want to make this line as accurate as possible. As you can see here, I'm going to have to fill out a table. So I'm going to use a slope multiple times to get as accurate of a picture. So going up 3 over 1, plot. Up 3 again, over 1, plot. And actually, I'm going to do this in pink so that way it correlates with my notes. Not really that important, but I'll do that for you guys. Going down 3 over 1 to the left, and then you're going to do your best to connect these dots together to get as accurate as possible. So the reason why I wanted to do that is so that I have like nice coordinates to write down. So like this is my first point. It's at -1, -4. So my x is -1, my y is -4. This one here is at 0 for x, but it looks like it's -1 for y. And then this one here is 1, 2, 1, 2. And the next one here is at 2, 5, 2, 5. So I have my functions table and I have the graph. This is very similar to what your project will entail. And so you'll notice that on this PDF form, I already have this linear line dotted out, and it's because when we're talking about inverse function, you're going to notice a reflection when you take the original function and you take the inverse of it and you graph it. You'll know this type of reflection is very distinct, and this here is the divider or the axis you want to reflect across. So you can see this is y equals x. It's also a linear line. As you can see, this makes a line, and this is x to the first power with a slope of 1. And you can see that the y-intercept is 0 because there's not one here, so that's why it intersects at 0 at the origin. So this reflection line is a slope of 1. Now, going back to finding the inverse, we have not found the inverse yet, and to do it, it's this simple idea. And let's go into the definitions before I find the inverse, so that way you guys can kind of remember some skills that you've learned in Algebra 2. So inverse functions are functions that reverse each other. So what I mean specifically is the function switches all the x and y values. So in this case, this f of x versus the inverse, they're going to switch x and y values. So in this case, the y values will go for the x. So in this case, -4, -1, 2, and 5 will sit here, whereas the y values for the inverse is actually the x values from the original function. So -1, 0, 1, and 2. So notice I have the x values from the original y values here for the inverse, and now the y values are the original x values. So now that I have a table, these tables hold coordinate points, which I will plot here. And so let's plot the first one. This is at -4, -1. So -4 down 1. I'm going to plot it with a green marker here. And then this next one here is at -1, 0. -1, 0 is right here. And our next one is at 2, 1. So that's going to be 2 up 1, plot. And then 5, 2, 5 up 2, and plot. And so now what you're going to do is connect these dots together and form your linear line, but this one is the inverse to the original line. And notice when you look at this divider here, right, if you treat this y equals x as your divider, notice how this pink line, the original line, is almost reflected across this line. So they have this symmetry along the y equals x line. And so if you were to reflect, you would get this line, the inverse. So two functions that are inverse of each other reflect over the y equals x line. And so it's not like you would typically think it reflects over the y-axis or the x-axis. It reflects over y equals x. And there's a reason behind it. And it's because we use this equation to reflect on is because the x and y's are switched. So that's why this equation or this line equation appears. But what I want you guys to remember is that when you have a original function and the inverse graphed, it has a symmetry across this diagonal that you will see. Okay, we'll see other problems that does this reflection, but that's the first part that I want to go over. So for A here, you'll notice we'll have a table. So this is very similar to what we did in the warm-up. If you're having a table, this part's a lot easier to find the inverse because all you have to do is switch your x and y value. So we're going to go ahead and do that. So for the inverse function, you're going to now have a 7, -1 instead of your x being -1, it's going to be that 7 from the y. And so I'm just going to switch the others. So 2, 9, 12, 4. And I'm done. So again, these would be coordinates points that you could plot, but you don't have to. But this would be the inverse function. All right. So now let's take a look at like problems like B and C, because those are a little bit more algebraic skills that you'll need. And they come from your Algebra 2 skills. So let me just remind you guys the skills that you've learned from your Algebra 2 class on how to find an inverse. So when it comes to finding, find inverse of your function f, if you want to find the inverse, you might remember this -1 represents the inverse notation. That's how you tell this is an inverse. The first thing you have to do is switch your x and y value. The second thing you'll have to do is solve for y after you switch them. So you'll switch the x and y's and now solve for y, meaning you have to get y by itself. 3, you want to replace the y that you solve for with the inverse notation. And that's it. That is my 3 easy steps for finding the inverse function. So let's try it out with part B here. So first off, we need to remember that f of x is really just a y. So I like to replace that first. And then the first step is asking us to switch x and y. So go ahead and switch them. Basically, you're going to just switch the variables. Don't switch anything else like the 4. Doesn't need to be on that side yet. So once you switch x and y, you're going to solve for y. So you have to get this y by itself. So first, we need to subtract over 4 to both sides. And so that gives me x minus 4 equals y cubed. To get rid of a cube, you guys might remember something called a cube root. Take the cube root of both sides. That will cancel out the power. Y comes down, and this is the cube root of x minus 4. Now, we're not done yet. Remember, mathematically, you want to change this to be the inverse of the function, so f -1. Or the f inverse of f. It's a lot of words. So that's going to be -1 f of x cube root of x minus 4. And so that there is my inverse function. So basically, once you get y by itself, replace it with the f -1 x notation so that you're saying that these two are directly inverse of each other. And then you could graph these two to see the symmetry, but I'm not going to do that here. Let's take a look at C. We're going to do the same sort of steps here as from above that we just went over. So again, this time they gave us a y instead of f of x. So I'm going to change this up. So first, let's call this x equals square root of y plus 2. So I've switched my x's and y's. And now I want to try to get y by itself. But first I have a square root. If you guys remember how to get a square root, you just have to square it. If you square a square root, they cancel, but you have to square the other side as well. So I have x squared equals anything that was inside the root comes out, so y plus 2. And then I need to subtract over 2 to both sides. So this is x squared minus 2 equals y. And then I have y by itself. Now, once you get to this part, I want you to notice that this started with a y. So you don't need f of x here. Instead, I'll just call this y. Y inverse equals x squared minus 2 instead of f of x since I didn't start with an f of x. And so this would be my answer. And that's it. I don't need to graph this or anything. For part D, you do have a graph. I do want to mention for part D, graphing can be a little bit tricky to know how to reflect across this axis. Again, this is the y equals x axis that you have to reflect across. So this here, it has like a cubic type curve. Typically cubics go this way, but this one is going the opposite way. So to reflect this, I want you to imagine if I were to fold this piece of paper right here, where would they go? And so when I look at this piece here, if I were to reflect it across this axis, it would actually hit here. Let's see if I can draw it really well or do my best to draw, but it would kind of like reflect like that. Whereas the other one would hit here. So this would be the origin. So I'm trying to pivot. And so this one would kind of reflect there. So notice if you were to fold across this line, this guy here would come around here, and then this guy would come here. And like I said, this is hard to do for beginners. So I wanted to show you guys this to kind of start imagining things, how lines would be traced out. But by no means would I give you a problem like this and try for you to try to figure out, at least not as one as difficult as like a cubic function. But I wanted you to start seeing it. One way you can do this without like trying to guess where things hit or how to draw them is to look at things algebraically. Now this is a little bit harder to kind of go through because it takes more steps, but I'll show you. But if you're okay with the drawing and want to move on to a different concept, then I would pause this video, go to the next video. But if you want to mathematically understand how I drew this picture, then stay tuned. So what I did was I understood, if you want to go the mathematical route, is I understood the original graph. This graph here is a cubic function. It looks like a cubic function. Now, I understand that a regular cubic function is x cubed, and it usually looks like this. Okay, notice that when you compare to this line, it's flipped. So this line is going like this instead. So what that tells me is that this equation is negative x cubed. And so if you understand that, then you can take this equation to find the inverse, to find this equation. So to do that, I'm going to take this equation to the side here and find the inverse. So I'm going to switch the x and y's. So I took this equation, switch the x and y's, and I'm going to try to solve. So I'd have to like think of this as like a -1. You have to move the -1 over by dividing. So you really have a negative x y cubed. To get rid of the cube, you take a cube root. And so that cancels. And so you have y equals 3 cube root. Now, some people are going to see the negative sign and they're going to be like, oh no, there's a negative under a root. But actually, this is okay because this is a cube root. Cube roots will take negative numbers. Any odd root will take a negative number. If you have a square root, that's not good. It won't like negative numbers. And the reason why is because anytime you square something, you should always have a positive number. But anytime you cube something that's a negative number, you can get back a negative number. It's totally possible. Like, let's just think about it. -3 cubed is -27. And that's possible. Whereas like if you had something that was squared, a negative that's squared, it should always come back out a positive number, never a negative number. So that's why it's okay for cube roots to have negative numbers. So this is our inverse function. And what you can do is take the original graph, this graph, and this function here, and graph them on Desmos, and you'll see that you will create this line here when you do that. So hopefully that helped you kind of more intuitively understand the mathematic behind it, at least from the algebraic side. Other than that, like I said, I'm not going to have as difficult of a problem with this one on being on a test. But I wanted you guys to see it. All right, that's it for this video, guys. In the next video, I'll talk more about determining if two functions are inverse or not.